This conference will now be recorded.
Good morning, everyone. So today we'll be starting with the VLSI functional verification interview preparation. So I'll be spending around 10-15 minutes just to give you a brief about what is this, why this course is being planned, and what all things will be covered, and what is the schedule. Basically, as you might have seen in the flyer regarding this training, I have mentioned that we'll be focusing on questions based on system Verilog language, the UVM constructs, uh, some of the test bench component development. I mean, when you go to interview, these are the things generally you face. Other than that, coming up with a test bench architecture for different types of designs, then how to develop a test case, how to develop a sequence, and how to map them. And how do you code by referring to a timing diagram? Let's say they will give you some kind of reset sequence, power up sequence, or some timing diagram. You will be asked to develop a driver code or monitor code for that kind of diagrams. Other than that, there will be some debugging based question. How do you debug an issue, right? Uh, then design bug reporting. I mean, how do you report the bug and how do you make sure that it is fixed? Those kind of questions will be there. Uh, Generally, this will be more relevant during the experience interviews, these kind of things, and these are mostly for the fresher interviews. Other than that, analyze the given code and find the errors in the code. They will give you a piece of code and they will ask you to find the errors in the code, how to fix that, and analyze the code and what the code does. They may give you a code and they will ask you to analyze what that code does, and they may ask you to even draw a timing diagram for specific protocol. So these are the various types of topics we will be focusing on. How these sessions will help the participants is, uh, now generally what happens during your office work, I believe a lot of the people who are attending are also experienced people. Your work is mostly limited to specific domain. It could be developing test case, or it could be debugging a test case failure, or it could be reporting results, or it could be analyzing the coverage. You probably don't work on all the aspects, and many times you don't work on the test bench development aspects where you have to develop test bench component, you have to develop reference model. That kind of work you don't do very often. But interview, when you go to interview, the focus is on the aspect that you don't do, right? They will ask you to develop some test cases, sequences, test bench components, right? So that is where you require some kind of additional preparation on top of what you do in the work to help you get through the interview, right? So this course provides that quick revision of all those topics in one place. I mean, if you see right now what is happening, you go to Google and search system like interview questions, you'll get 200 questions. UVM also you'll get, but you really, some one of the problem you face is they don't match the quality of the product company interviews. There'll be simple questions or some complex questions, and even there is no video resources on how to prepare for the interviews, the technical questions. So I thought, why don't we set up one such course? And we did had time to do this activity. I mean, what is the time we need is, we need people to collect the questions actually. I mean, because it may add up to almost 2000 questions or even more than that if I put together all this Verilog SVUVM, right? Much more than 2000, 2500 questions it may add up to, because the way I see in each topic, and I have almost 80 topics or 100 topics, and each having 30 questions also adds up to 2400 questions. So I thought we could cover some of those important questions. I'll also explain how we are going to do. You may ask, how can you cover 2000 questions in 6 weeks? So I will tell you the plan also. See, what we have done is, I have just listed down each and every topic in the system Verilog, small, big, everything. I mean, functional verification overview, language concepts, basic features, literals, data types, static arrays, dynamic arrays, queues, associative arrays, operators, everything. Uh, then even a fork join, everything in system Verilog we have kind of listed into 43 topics, subtopics. That is what this one is. Similarly, UVM topics are also listed into around 29 topics, including everything: UVM basics, base classes, UVM test bench architecture, UVM phases, questions based on test bench example, questions based on UVM root, UVM command line processor, reporting classes, factory, configure and resource DB, TLM, sequencer, monitor and scoreboard development, sequence library, different ways of developing UVM too, and then different styles of sequence coding and advanced sequence methods like lock, grab, those kind of questions, and TLM 2.0. I mean, if you see, I tried to basically, for my purpose, institute purpose, I wanted one such database actually. More than this course, I wanted, I mean, I was always having that thing where how do I develop one such database for the institute so that it helps the my institute batches, regular batches. I thought this will automatically align when I'm doing this, automatically this will happen where because I'm offering the course, I will be kind of forced to come up with a consolidated database of everything. Now, like this, I have topics for Verilog also. I'll show those things. Okay. Every week, basically, what we are going to do is we are going to select few topics every week because I'm not going to randomly do questions from different places. Then we won't be able to focus on completion. I mean, even after 6 weeks, you will feel that 5 weeks, you will feel that training hasn't completed. Some topics are left out. So rather, what we'll do is we'll focus, select specific topics. For that week, we'll only focus on that topic only. All the questions related to the topic. One thing you need to notice: these sessions are not just for interview preparation. It also helps with day-to-day work. I mean, it's not just to make you clear the interviews. It will help you when you get into the, I mean, when you start working on the project also. And also note that people join from different backgrounds. Someone may be a fresher, someone could be even 5 years experienced person, right? So there is a their ability to understand things will be different. So I may not always do very difficult questions. I may even do some medium complexity questions. Please be in mute. Someone. Right. Those who are not in mute, please be in mute. Okay. Questions are divided into below categories actually. What is the approach, training approach will be? Any topic you take, let's say today I'm going to do constraints. I'm going to divide the constraints questions into two categories: theoretical questions and the problem solving or practical oriented questions. So theoretical question, it's more like a definition. What is RAND-C? What is RAND case? Okay, what are the types of constraints? That would be theoretical questions. What is practical solving and problem solving questions? We'll divide them into three categories: easy, medium, and difficult, because we are working on a tight timeline. I mean, we don't want to do 200 hours course. We have a limited time. In that, what is that best we can do? So we'll try to focus more into medium complexity and difficult kind of questions. I mean, medium is something that is targeted for freshers who want to get little complex exposure to the language, and difficult is for the people who are trying for product companies. Actually, I mean, the product difficult is the one which is generally asked in the product companies. I will be covering those things. Other than that, participants are provided with all the set of questions before the schedule. Uh, is everyone able to see the screen shared?
Yes, sir.
Yes, sir.
Yes.
Yeah.
Yes,
Uh,
yes, yes.
Shashank, please join the session again. Please log off, join again. I think what you have to do is, because there is a lot of participants, right? You have to go to the top and hide everyone in the top of this thing, right? I mean, top of your window, there will be option to show everyone, hide everyone. That if you do, you will be able to see the screen shared. I mean, yeah. Now, what is the expectation is that, please understand this point carefully, that let's say we are talking about 2000 questions. I won't be able to do 2000 questions in the session. Let's keep the expectation realistic. When you should not come after 5 6 weeks, you should not come and tell me that you never did 2000 questions, and it's not possible. Okay. Why I am telling again, to keep the expectation realistic, and so that if someone doesn't find it suitable for them, they should not enroll. I mean, if they think that it's not meeting my requirement, don't enroll. Okay. uh, we expect participants to work on some of these questions during the week. You take 2 hours or 1 hour in a week and you do it. Like medium and difficult questions will be discussed during the session. I mean, we may discuss some theoretical questions. We will mostly focus on medium and difficulty category questions. We will keep the discussion open. What do you mean by discussion open is, I am not the smartest person. Everyone has ideas, everyone is smart. It's just that we have to put together our approach and make the session more interesting and more engaging, because if you expect only me to come up with efficient solution for everything, probably it's not going to the best session. Because there are some people who are with experience level, who has some expertise in specific domains, they can come up with a better idea of doing the same question. So you always keep that open, and wherever you have suggestion, you feel that this question can be done in better manner, please do that. In fact, that may be the what interviewer is expecting actually. See, same question may be done in 2 3 ways. He may be looking for approach where it can be done efficiently, and you can always share that with us. Collectively we can make the session lot more effective. Now we will be listing questions for every topic. For example, if I go to constraints and randomization, we have, that's what I told, right? We have around listed the questions starting from very basics of theory. Then we have questions on easy category, medium complexity category, difficult category, various things are there. Okay. uh, so you can also post your questions. I mean, see what happens generally, you will be attending interviews. What we have done is we have created one such link where you just go to this link. You can post your question here. I mean, I have given that specific topic, like system verilog. What is the question specific to which topic you are posting the question? Uh, and you can post your question here. So what we will do is I'll include that question in the list. And if it is required, we'll discuss that question during the next session. Okay. This will help everyone. When wherever, let's say you face some interview, you find it difficult, and you don't find it among the question list of questions that we have, please fill this form and update it. Every week we'll be updating our list with this set of questions. So what will happen is this will all have a consolidated list of questions. I mean, collectively we can benefit out of it, and I'm going to give you access to these all these questions. I mean, not only constraints, what we have done is like this for every overall topic we have listed into various category. I mean, all the questions we have consolidated. Let's say for each and every topic, we have prepared a questions, prepared a list of questions for each and every topic. Same thing we have done for UVM, everything actually. So these questions is what I'm going to discuss. So initially, instead of starting off with very basic topic like arrays and data types, operators, I thought let's start with little complex topic, uh, constraints randomization, constraint random verification, directed verification. That is what I want to do for today's session, because generally people will have a lot of energy during the initial part of the training. As you go to the 6th 7th week, I mean last end of the training, participate attendance will be 50%. I mean, that's the general trend. So I thought let's, during the initial 3 4 weeks, I want to focus on more important things. Okay. Like this, I have given a schedule. See, whatever topics we had, I have split it on a day-wise basis. Day one, day two. See, in day two, there are simple topics like literals, data types, arrays, queues, and associated. They can be covered in one complete session. Everything. Like the day three, what to cover. Day four. I mean, you see, day three, day four is mostly focused on the object-oriented programming. Day 5 is focused on the other aspects like interface, program, task, and functions. Day 6 is covered on functional coverage, code coverage, and assertions. Okay. I mean, we may keep 1 or 2 days as a backup, because at the end, the session should be done to the satisfaction, not just topic is completed. Rather, have we covered the important part of the questions? That's what I will also be focused on. Day 7 onwards, we'll be focusing on UVM, and up that is still 12 days. When I say 12, day 12 means one Saturday is like day 1, Sunday is like day 2, next Saturday is day 3. Okay. If participants are convenient, we may even plan some sessions for weekdays in the mornings, 1 hour in a day, like 6 to 7 or 6:30 to 7:30. That way we can distribute the overall load, if participants are convenient with it. And we will also have few days where we'll be focusing on test bench component development, test bench architecture, test case coding, whatever topics we discussed, right? Earlier, all those things, debugging based questions, design bug reporting, fixing those things, all those topics will be covered. So this is about it. There is similar to there is a similar split for Verilog also actually, but I probably won't be able to cover them in the live sessions except for maybe few important questions, questions related to race condition, blocking, non-blocking, pipelining, some questions on FSM. We may cover those questions, but I probably won't be going deep into Verilog. But I will be giving you access to each and every topic, all Verilog questions, all system Verilog questions, all UVM questions, all test bench related questions, everything. So you can work on those, and whenever you have questions, we can always discuss those questions in the during this session. It's not going to be one-way session. It will be an interactive session where you are always encouraged to ask your questions. Okay, so let us start off with the one of these topic, constraints and randomization. Basically, I would say this is not just constraints. Okay, we are going to talk about constraints and randomization. Again, I'm not going to teach theory. I'm not going to go through my system Verilog presentation because that is not the purpose of this session. Purpose of this session is to take some of the questions as we discuss theoretical, practical, and discuss those things. And as and when required, I may be running the same things in the tool also, because even you should make that practice rather than just writing it on a paper and thinking that it is done. Always keep the simulator open and just run the things on the simulator so you know that it is working also. Syntax errors wise, everything will be good. Okay. So we'll be discussing some of the things in some of the important things in constraints. I wanted to talk is when you go to complex things, right? They may ask, you may have to generate some kind of patterns. So whenever you are asked to generate a patterns, uh, you have to store the earlier generated values into a static variable. You have to store them, keep them stored. Then using this generated values, you need to write constraints such that you generate the next value accordingly. Let's say they will ask you to generate a pattern like 110 110 110, for example. Okay, how? Using constraints. Okay, you may say, what is there in this? You write at the rate of passage of clock, data equal to 1, next passage of clock, data equal to 1, at the rate of passage of clock, data equal to 0. Repeat, just repeat that forever, so it will automatically generate 110 110 110. That would still do, right? But they will ask you do that using constraints. So how to do that? So that is where you have to store the variables into a static or some global variable. Use that in the constraints to generate the next value. We'll discuss that. I'm just giving you some of the techniques that goes into solving the complex constraints. Next technique you could do is processing the data in post randomize. You cannot, sometimes you cannot do everything with constraints. You cannot do everything with constraints alone. You cannot do, you have to do some kind of additional processing in the post randomize. That is also one way to solve the complex problems. Third way is implication operators. Implication operators are very important concept, and even iterative constraints. There are two types of things. Implication constraints and iterative constraints are very powerful constraints. We'll be talking about all those things. So now let us go over some of these questions. As I said, what I will be doing is I won't be reading through the theory questions. See, I'll just give you what kind of questions I have. First of all, why constraints are required? I mean, what is the relevance for these questions? When you go to interview as a fresher, they can ask you any of these questions, right? Why do you require randomization? Why constraints are required, right? What is the significance of rand case? What is significance of rand C? What are the types of constraints, right? There can be such questions. And what is difference between directed verification and constrained randomization? Sheikh Sheikh Kutsia, please be mute. So like that, see what we have done is I have listed down the set of questions. Why constraints are required, need for randomization. Can we use randomize on integer and bit vector? So what do you think? Is it possible to use randomize on integer or bit vector? Can we use randomize function on integer or bit vector? Is it possible? It is not possible, right? We can use randomize only on the objects. randomize can be used only on objects. So then how do you randomize an integer, let's say a? You have to use
Srinivas?
the system tasks. Yeah, please tell me.
Yeah, I'm Kishore Srinivas. So
Yeah.
we can do randomize on integer, no?
How can you, I mean, can you do a dot randomize? If I have
For
integer a,
example,
is it
A
possible?
is a variable you are saying. Any variable.
Yeah. Yeah.
For example, A is any variable. We can do like, oh, you are saying like object.
A dot
You mean to
Object.
randomize
say,
cannot be done. What I'm telling is you have to rather use a equal to dollar random or dollar u random, dollar u random range.
mm,
Some of these things you have to use. This is not possible.
mm. But dollar random is a Verilog concept. If you go to system Verilog, like we can do the A dot randomize, no?
No, you cannot do.
what
Integer is
Srinivas meant
not an
was,
object. Randomize is a method of a object. You cannot. This is not allowed. Only objects can be randomized by object name dot randomize.
Of course, if you declare A as a rand and object dot A dot randomize, can't we do like that, Srinivas?
No, we can't do that. We can't do that.
Okay,
We
okay.
can't do that. Okay. Yeah. Next question. Can we randomize a string? The string gets randomized. Let's say if I declare, for example, this is question Q4. So whatever I will be coding, I'll be sharing these codes with you. Okay. Some of the questions. Oh, sorry. Sample class, sample, end class. If I write string name, uh, rand string name, module top, and module. If I randomize, does it get randomized? Please tell me. Does the name get randomized in this case? When I declare a string, does the string get randomized? Okay, string cannot be random. I mean, one of the basic things is that string cannot be random. So these are the some of the important aspects of randomization. Then how will you randomize a string? Let's say I want to generate a random string. You cannot use randomize, and you cannot even do string equal to dollar random. Can I say name equal to dollar random? Can I say s dot name equal to dollar random? Will it work? It may work. It won't work because it will be mismatch in the data type. Then what do you think I should do? How do you think we should approach this problem? So generally what happens is name, you don't want it to be completely random, right? You don't want name to be completely random. There will be some kind of pattern. You want to generally have a some kind of pattern. So that pattern will be Q4 solved 1, Q4 1 dot sv. So in that case, what I will do is rand int num. I'll declare one number, some number. Okay, I mean you can use this kind of concept. Don't declare it as a random. Whatever, let's say you put a constraint on number, num less than 10 and num greater than 1, for example. Is this constraint possible? num less than 10 and num greater than 1. Is it possible? I think it should be possible because it's only one single relation. Next, what will I do? Function void post randomize end function name equal to whatever you wanted to give. Let's say dollar s format f. What is s format f stands for? String format f. I mean, it converts some something into string format. Name whatever you wanted to give. Let's say, okay, variable percentage 0d comma num. Now you run it. So how do I run it? I will be having one run.do file. I'll be just changing this. Everything else will be same. This is what you should also practice. You should also do. Now you see that compilation error is not there. Why it's not there? String should never be declared as a rand variable. Now you see it is generating a variable 4. It's generating variable 4. If I generate with a different seed, in this context, can someone tell me what is the significance of a seed? What is that I should give? SV seed. I just give SV seed, automatically it takes. Now it will generate a different variable, different name, variable 3. If I go and again change this to something else, let's say 121, 1232, it will generate a different. So in the same context, let us discuss what is the importance of a seed, because as and when something is important, let's discuss that also. What is the importance of CDs? I have a presentation there itself. Let's discuss. Basically, seed is a input to the tool used as a starting point of for randomization. How do you pass a seed in QuestaSim? We pass as -sv underscore seed, whatever seed you want to use. Seed helps generate different random patterns for same test case by using different seed values. What is the significance? Can someone tell me why do we use seed? This is one important question in the interviews. I mean, what is the use of a seed?
To check all the possible scenarios.
Not that is not exactly not the only reason.
So in my case, if I have about 10 variables,
Yeah.
so during the first run, I may get some kind of values. So that might be covering some kind of functionality.
Yeah.
So when I'm going for the next time with a different test case, so that time I may not be expecting the same values. I'm looking for the different values. So better we take another seed so that it will cover other functions.
Thank you for that. Let me explain. Okay. Seed is generally used for two purposes. Okay. The first purpose is when running a test case, when running a regression. The tests run with different seeds. A failing test case or a failing test case, we fix the issue. We check what it, we analyze what is causing it to fail. Mostly our assumption is what? Test bench is not issue, it will be design issue. I mean, we are only interested in design issues. So report this design issue to the RTL team, RTL design team. What they will do? They will fix the RTL. release the new fixed version, the new version of RTL. What is how to prove that your bug has been fixed? How do we prove that? How do we confirm that the bug has been fixed? Tell me, how do you confirm? Run the test case, run the failing test case, whichever test case failed, with the same seed, ensuring that no changes happened to no other changes were done to the test bench. I mean, what is the purpose of running with the same seed? Running with same seed is making sure that the pattern is getting generated, making sure that the same pattern is getting generated as part of the, and design is getting checked with the same pattern. So if the now with the same pattern, if test passes, it means that design has been fixed. You may say, what if I use a different seed? Now the question comes, what if we use a different seed? Since different seed will generate a different scenario, you cannot say that your bug has been fixed, because you are simulating in a different pattern. You are generating a different pattern. So there you cannot give guarantee that you are stimulating the design in the same manner as earlier. So hence this is very important. This is first reason. Second reason is, of course, whatever everyone has told. What is second reason? Second reason is that, what is second reason? To cover, not the starting point, to cover different parts of the design. I mean to say, it's like you can take this is your design. If you don't use seed, every time you randomize, it'll generate the same scenario. That means only one path is taken. Other portions are never hit. Whereas by using seed, different seed, what happens is it something else gets checked. I mean, you see different paths gets exercised by using different seeds. So finally it ensures that all the possible scenarios gets exercised when you run multiple iterations of the regression. So I hope this is all clear to everyone, why we use seed concept. So one is for what? To make sure that we exercise all the possible scenarios of the design. Second is to confirm that whatever failing test has been fixed in the fixed version of the RTL code.
Sir, I have a doubt here.
Yeah, please tell me.
Sir, so for every failing test cases, so we are going to store the seed so that we can run the same test pattern again, right? But how
Yes,
can
yes.
we ensure that though we give the same seed, like each time when we open up the tool, will it the same pattern be generated for the same seed, sir? Like, or how does it
Exactly.
work?
Yeah. Tool
Okay.
tool is not completely random.
Okay.
Actually, what is seed is? Seed is the see what is seed? First of all, let's understand. Tool is not perfectly random. It also needs a starting point for randomization. It also needs a starting point for randomization. If same seed is used, and given that test bench did not change majorly, it will always generate same pattern. Is that clear to you? If same seed is used, if you didn't change the test bench, let's say you change test bench entirely, there is no use of no use of using the seed because you have changed the test bench. That is where the tag and everything comes into picture. See, when you are working in your project, right, there will be tag, previous tag, the new tag. What you do is in the previous tag only, wherever you failed, there only you take the RTL changes. There you prove that it is working. You don't do it on the new tag. You don't do it on the new tag of the test bench and RTL. You rather take the same tag where you ran the regression. There you take the updated RTL code, some few files which got updated. There you run and you prove that bug has been fixed. Yeah, I think Akash, right? Is it clear to you?
Yes, sir. Thank you.
Okay. Yeah, anyone else has questions? What is the use case of pre and post randomized? Can someone tell me? Sixth question I'm doing here. What is the use of pre randomized and post randomized?
Is called before objects are randomized, and post randomized are called like after objects are randomized.
Okay, that is one thing. So what is the use case? Why do we need pre randomized?
Pre-randomizing is required whenever before randomizing, supposed to need to maintain some values.
Uh, if we want to switch off some randomization for some of the variables, we can do that in pre-random.
Okay, fine. Let me explain why we need pre randomized and post
One of
randomized. Generally,
one of
yeah.
one of the application which I know about pre-rand post is that if you want to do write and immediate read test cases, so we can do using the pre and post like that also.
Okay. Thank you for that. Let me explain. Okay.
Okay.
Uh, as you know, pre-randomized and post-randomized are called as what? What are these methods are called as? These methods
Callbacks.
are called as. These methods are the callbacks of randomized method. What is meant by callback? Anytime you call randomize, automatically pre-randomize gets called before the randomize, post-randomize gets called after the randomize. What do you think pre-randomize should be doing? I mean, pre-randomize use case should be for modifying the randomized behavior. I mean, if for some reason we want to modify the pre-randomized behavior, we do that in we want to modify the randomized behavior, we do it in pre-randomize. If for some reason, again, we want to change or update the randomized values, or do some calculations, or do some analysis based on randomized values, where do you do it? We do that in post randomized, because by the time you come to post randomized, already values have been randomized. So let us take one simple example to understand that. What could be the use case of pre and post randomized is, generally, if I don't if you take any example, I have a class, let's say app transaction instantiated as tx. Just take a little complex, let it be ax. App will be very simple, so let's assume that it's ax transaction. If I have 10 test cases, in all test cases, if I just do transaction.randomize, just one, You may say, are you going to only do that? No, I'll be doing more, maybe for loop, different things. Do you think will there be any differentiation in these test cases? If in all the test cases, if I just do transaction dot randomize, will there be any differentiation in the behavior of test 1, test 2, test 3?
No, sir.
Same, right? So there won't be any difference. There will not be any difference. There won't be any difference between above test cases. So then the question comes, how do you differentiate them? So because you don't want to generate the same scenario in every test case, right? In one test case, you want to generate burst type. In one test case, you want to target burst length. In one test case, you want to target protection type. Different things you want to target. But by generally calling transaction randomize, you don't have any way to differentiate test 1, test 2, test 3 up to test 10. So then the question comes, how to differentiate? How to create that difference? It can be done in two ways. One of the most commonly used, can someone tell me what is that one of the most commonly used? How do they differentiate one test case with other test case? Basically, different test case means what? Something where you generate a different scenario, different types of transaction, different randomization pattern. So how do you do that?
One case we can write constraints nodes.
Common sequence, base sequence.
Yeah.
So to that base sequence, whatever the modifications we want to do, we will take in different sequences, and we will append on the top of that base sequence.
Okay, I'll explain. Thank you for that. But let's go to the correct way. First way is inline constraints. By using inline constraints, you can differentiate one test case with other test case. Let's say you have written a what is the example here is, what is the question number here? We are talking about queues. Assume that I have class Ethernet packet and case. I have rand bit 7 down to 0 payload. Rand int length. If I want to generate class generator end class Ethernet packet PKT, then I have task run end task. Let's say I have case test name and case test small packet. Test medium packet. Test large packet. Don't literally take where is source address, where is destination address, where is length, where is type. Just understanding pre-randomize and post-randomize. Don't literally take Ethernet packet. Okay. In this case, if I just do pkt equal to new pkt dot randomize, will it do that? Will it generate a small packet? No, right? It won't generate. There are two ways to do this problem. Two ways to do this. That is where we can either use pre-randomize or we can use either inline constraint. So the solution is what? Use either pre-randomize you can do it either by using inline constraints or by using pre-randomize. Let us try to understand both the approaches. How it will be done using inline constraint, how it will be done using the pre-randomize. So in case of pre-randomize, in case of inline constraints, what I'm going to do is I am going to set one thing called as rand bit rand packet type. What is packet type? I will declare as enum bit 1 down to 0. What all packets do I want? Small, medium, large. Do I need to give the values to them? Not required, right? Automatically it will take 0, 0, 0, 1, 1, 0. In this case, I can write a constraint, packet type underscore C. So what I will do, what type of constraint should I use here? So there is a payload, I did a mistake, payload Q.
Implication.
We should use what type of constraint? Implication constraint I should use. What is that I'm going to do implication? Packet type equal to small. Length inside one to length inside 1 to 30. If packet type is equal to medium, length inside let's say 31 to let's say 75 for example. Next is what? Large. 76 to let's say eventually I'll write dollar. Can someone tell me what is significance of dollar? Any maximum possible value. Any maximum value. Does it mean that will it take 1000? It can take anything actually speaking. So but yeah, so we should actually not keep dollar in this case. We should not keep dollar. Reason being, this can take anything, any value because it is integer. So how do I limit that again? If I want to limit length inside 0 to 255 something, whatever length you wanted it to be. I mean, you may ask, why are you writing? You could have written 255 here itself. That is also fine. No issues at all. If you want, you can avoid and you can just write 255. That would have been fine. Then what is other constraint I want to use? Payload dot size equal to length. Typically, here if you see, we are mixing two constraints into one single constraint. Is it correct? Is this correct approach? Do you agree? I'm mixing two constraints. See, this is implication constraint. This is some other simple constraint. I'm mixing both of them into single constraint. Is this suggested?
No, sir.
It is not suggested. Why is it not suggested to do? You lose control over randomization. What is meant by lose control is, I can write one more constraint. I'll move this here. Actually speaking, there is no difference between what I'm doing now and what I did some time back. Both of them are same. See, whether you keep it here or whether you keep it inside this, absolutely no difference at all. Both will give you the same behavior. But why do I want to do this? Whatever I did now, why do I want to do this? Can you tell me? What do you think is the motivation for me to do this?
If we want, we can. Sorry, sir.
Thing is, primary reason would be, there is something called as constraint underscore constraint mode. What I can do, if I want to disable one of the constraint, I can disable. Rather, if you keep everything in single constraint, you have only option to disable everything or enable everything. Whereas now, if I don't want this constraint, I can disable it. If I don't want this, I can disable it. So that is the reason. Otherwise, in system Verilog, you don't need to code 20 constraints. You can keep everything in single constraint. Just see, every constraint is a statement. See, this is one statement, this is another statement. You just declare everything as a statement, keep all the constraints into single thing only. So that could be another important question for you. Why it is not suggested to keep all constraints into one constraint? You understood, right? Coming back to the original topic, what is that we were talking about? How do we use it? Now this is where I can use the inline constraint. Whereas if I do this every time, if I don't use inline constraint, if I just call packet.randomize, and let's say if I print the payload $display, what is it? Length equal to percentage 0D, packet type equal to percentage. Can I print enum as a string? Is it allowed? It is allowed, right? I can print packet dot length, packet dot packet type here also. But if I run this now, how do I run this? I have a generator, module top, in module, gen equal to gen underscore I, new, initial, begin, end. Shall I call gen I dot randomize, or what should I do? If you look at this code, what should I do? Generator, shall I randomize, or what should I do? I should call gen I dot run. The run task I should call. This run task I should call. And if I do that, automatically everything will happen. Now, let's change it to Q6. Undefined variable test name. I did not define test name, right? So what is the easiest way to do this? Since I'm using it in the scope of the generator, what I will do, I will declare string test name in the global scope. String test name in the global scope, and here I can give the value test small packet. And if I run it now, so the compilation is clean. Is it generating a small packet? Large packet is generating. So that is the problem. If I just call packet.randomize everywhere, if I just call packet.randomize without using any inline constraint, what happens is it doesn't differentiate. It doesn't differentiate whether I should generate small, large, or medium. It doesn't do. So that is where what I could do. One of the approaches. Tell me. One of the approaches is use inline constraints. How do you use inline constraints? With, what can I do? Packet type equal to small. Here what should I do? Medium, large. Now what should get generated? Small packet should get generated. Still it's generating large. Why? I did not change the file name. Now it should get generated small packet. Small, length is 11. I'm not printing the payload because it is not important for us. This is important. Length is 11 and packet type is small. Okay. One more thing is, this is one way of doing it. What else can I do here? What is the other way of doing the same problem? Is using pre-randomize. This can be done using pre-randomize. So how do I write pre-randomize? Where should I write pre-randomize? Shall I write it in the Ethernet packet? Shall I write it in the generator? Pre-randomize, should it be done in the packet or should it be done in the generator?
Ethernet packet.
It should be done in the packet. I mean, it should always be done in the packet or the transaction class where what you are trying to randomize, because you call packet dot randomize, right? So when you call packet dot randomize, The pre-randomize also should be of the packet only, not the generator. So I should write where? I should do it in the pre-randomize. Okay. Do I have to write it here or can I write it below constraints? I mean, where do I write the pre-randomize? Should I write above the constraint or below the constraint? Pre-randomize. What will happen if I write below the constraints? Will it take effect? Doesn't matter. See, the thing is, task and function, wherever you write, doesn't matter at all. So it doesn't matter whether you write here, whether you write after the constraint. How to write it? Function void pre-randomize end function. What to do here? What to do? Same relation I'll keep. First thing, what I'm going to do, packet type dot. What should I do? Disable the randomization. Disable the randomization. Whatever you did here, you do the same thing there actually. Also it will work. I go here. I will explain this. Let me just first show you and run it. Now what should get generated? Small packet only, because our test name is same, small packet test only. You see, the generating, second thing you will notice is it's generating the same length and same thing. Because why it generated same thing? Why it generated length equal to 11 and packet type equal to small? Because we ran with the same seed. Both the scenarios we use the same seed. If at all I change 32 to 33, will it generate different pattern? It will generate. Even you change by one number also, plus one, minus one also, it will generate a different pattern. Now you can see. Packet type is small. That is because that is the constraint we applied. Length within the legal range it will take. Now if I again go back and change it to 32, again give how much length? 11 only. That is the significance of the seed. In regression, where do you get the seed from? Let's say you ran regression, 20 test cases failed. Where do you generally get the seed from? In the log file, it will be there automatically. In the top, there will be option when it is running, it will tell you this test is run with this much seed. You can see this. Next, this is the second way of doing. But which one was easier, using inline constraint or pre-randomize? Inline constraint is easier actually, because see, you don't want to really play with transaction class, because transaction class is very sensitive. I mean, any changes you do, it breaks everything else, right? Because not only generator, everything is else dependent on the transaction class, right? Scoreboard, monitor, functional coverage, everything is dependent on the transaction class. And typically you don't want to impact such file which every component is using. Typically, though, it is possible to do in both the cases, where you do the update in the pre-randomize also, you do the required behavior in the inline constraint also, but we generally prefer inline constraint. So let us try third way of doing the same problem. I can do the same thing here also, exactly here. Packet dot packet type dot rand mode and mode 0. Then you say small, then you don't need. Then you don't need to use inline constraint. Because now that you have disabled the randomization, what is the significance of disabling? When you randomize, that will not get random. That will not get randomized. Because it does not get randomized, whatever you value you give, it will take effect. It will be small. When it goes and generates the value, since it is small, this relation will take effect. Same thing I can do down also. Y2. Large, medium. What I will do here, let's go and run large packet test. I have to change it to generating a large packet. So that means there are different ways of doing the same problem. Generally, what people prefer is always using the inline constraint is the easiest way to do this. Do you understand what is the whole discussion is about? Discussion is about how do we create different test cases. There are two ways. One is using inline constraints. By using inline constraint, you are able to randomize as per your requirements. One is using pre-randomize. In the same context, what is significance of post-randomize? Can someone tell me what is the use case? I mean, this could be how you can face interview question. I mean, where do we use post-randomize? It is very important. Okay, where do we use post-randomize? Give me any practical example where you will use post-randomize.
If we want to do any calculation after, like CRC calculation.
Yeah, post-randomize is used for multiple reasons. I mean, calculations based on randomized values. Example could be, let's take an example of AHB transaction class. In AHB, you know that there is a wrapping boundaries, wrap lower boundary and wrap upper boundary. When you study AHB protocol, you will see that AHB supports wrap transactions. There will be a wrap lower address, wrap upper address. These cannot be randomized. Lower address and upper address, these are calculated based on the address and burst length and burst size. Okay, understand. These are calculated based on what is the address, what is the burst length, and what is the burst size. But you cannot directly generate a random address, random lower address, and random upper address. So what do? We generate wrap addresses in the post randomize function. Now, how do we generate further? We need to understand the AHB protocol in depth. What is wrap? What is lower boundary? What is upper boundary? This is one of the example. Other example could be what, as most of the people were telling, CRC calculation. We can do the CRC is based on the payload, right? So payload only gets generated during the randomized function. So you can do it in the CRC calculation in the post randomize. What could be the reason for randomization failure? There could be two reasons. What could be the reasons for randomization failure?
Taking different constraints.
One is conflicting constraints. What is the other reason?
like you told, like disabling one maybe not causing other to random.
Basically, some non-random variable used in constraints. Basically, there is a variable which you haven't declared rand, but you are using it in the constraints. These are the generally two reasons why randomization fails. How to fix that? I mean, generally tools will give you the reason. If not, you can use this approach. I mean, every tool will have one option, like elaboration time option. Like for example, in case of Questa Sim, there is an option called a solve failed test case, failing test case, and solve failed debug equal to 2. They themselves will tell you, use this to get more information. Then it will tell you what scenario, in what is the constraints which are conflicting, why it's failing. The tool itself will report you that in detail. This is conflicting with this. That's why I'm not able to randomize. So hence I'm failing. These are the things.
VLSI also, I guess there is
VCS.
debug,
Yeah, it will be there, of course. Every tool will have that. The only thing is you need to figure out what is the equivalent such option in the VCS and NCC. Where do we generally write the constraint? Can we write constraints in a generator class? Only transaction and only packet, nowhere else. What is the type of constraints we use in generator? They are called as inline constraints. We will discuss this through one example. What is the significance of new in RAND and RAND? Can someone tell me? This is also important. What is the significance of new with respect to RAND-C? I think RAND-C is sufficient. Let's say one variable is RAND-C. What is the significance of new for that? Did everyone understood the question?
The cyclic nature will be broken, and we won't be able to get the actual functionality of RANC.
Yeah. So basically what happens is, if we use packet equal to new, it will reset the RAND-C behavior. What is RAND-C? Cyclic randomization, right? What is meant by cyclic randomization? A pattern where every possible value have the equal priority, equal weightage. Every possible value has equal weightage, and only once all the values have happened, the next value will happen. Rand cyclic means what? A randomization pattern where the RAND-C variable has a equal weightage for every value. But when you reset it, when you do new, it gets resetted. So when you generate again in a new, it won't follow the RAND-C behavior. So how to solve this problem? How to fix this problem? That means I'll give you one simple example. Down to 0A, let it be RAND-C. Module top, module, sample S equal to new, initial, begin, end, S dot randomize. Let's say I will do it 10 times. Let's say I do S equal to new here. What is the problem with this code? Can you tell me? In a module top, in the initial begin end, I'm doing S equal to new, then I'm calling S equal to S dot randomize. What is the problem with this? The problem will be, we won't get the RAND-C behavior will not hold. See, ideally, what is that we would expect to generate if I go here and run it? Is it holding the RAND-C behavior? Repetition is happening, right? 4 is repeated. 3 times, multiple times, 5 is repeated, 7 is repeated. Things are getting repeated, which is not Rancy behavior. Can you tell me what is that is causing Rancy behavior to get broken? Where? 10th line. So we should never do 10th line in that case. We should not do 10th line. Next, if I run it, will it now get the Rancy behavior? Will it give the Rancy behavior? Yes, it will give. You see here, it got generated, all possible values, no repetition. Then only the next pattern is starting. This is what is it here? What are we getting? Equal weightage for every possible value. That is what is Rancy behavior is. But here there is a problem. Let's say I'll go to this also has a new problem. What is the next problem is with this is let's say I am putting it into one mailbox. What am I doing? I am putting it into one mailbox. In another initial block, after some time unit, let's say after 5 units, because by the time 5 units, everything would have been put. Because how much time will this repeat will take? How much time this repeat is going to take to execute?
0.
0 nanoseconds. Because there is no time here. See, repeat 10 doesn't mean 10 nanoseconds. It's like you have to add how much time this line takes. Tell me how much time it takes. 0. Display takes how much time? 0. Putting into mailbox also takes 0 time. So overall it will take 0 time. Repeat 10 also takes 0 time. So now you may ask, why did you use 5? I can use 1 also. In that case, if I now write repeat 10, if I do mailbox.get s, I will use some other s also because so that you don't have any confusion. S1 I'll call it as, and I do s1 dot print. I will just say putting. Here I will say getting. You understood, right? One is putting, one is getting. So I will go and change it to _1. We'll do it. Where do you think I should declare? Tell me. What is the easiest way to do it? Declare in the global scope. If at all you want to keep it very easy, just declare it in the global scope. Otherwise, you have to keep it in a class and use it as a static variable. Now let's see the problem. What is happening? I mean, see, putting is fine. It is generating different values. 1, 2, 5, 6, 3, 7, 0, 4, 4, 1. But while getting, what is it getting?
Only the
Same values.
last
Is it
value.
correct? Why do you think? What do you think is the problem with this?
The handle is being passed, so the last, so the handle is not being updated, so it's the same handle
So,
which is being passed.
is it putting the first one or is it putting the last one?
The
It's not
last one.
putting first
Last
one,
one.
it's putting the last one. So how to solve this problem?
Store it in a separate variable and assign a new.
Yeah. Basically what I have to do in these cases is I have to use one more variable called as s temporary. So whenever you have rancy, not just rancy, make it a practice. Always make it a practice. You always do s_p equal to shallow copy s. Now because of this, what happens is you are creating new means a new object is getting created. And whatever is the value of s, that gets assigned to s underscore t. And what are you putting into the mailbox? S underscore t. But what are you randomizing now? You are randomizing a different thing. So hence, this won't get disturbed because you are creating a new object. S underscore t will not get disturbed. This will solve the problem. Have you understood? Always make it a practice that whenever you are putting into mailbox, don't put directly. Whatever you randomize, don't put it. Always just do the shallow copy or maybe deep copy and then put it. So that what happens is, this is not going to impact this one.
Is going to be done dynamic value. Why that conflict is why it is taking last time.
It is because what you put here is we put object into the mailbox. We don't put the actual value. We don't put all the elements. We put only the object handle, not the actual contents. And since you are not doing new, the same object handle is getting randomized. So essentially what happened here is, in 10 calls, if this is my mailbox, all 10 of them are pointing to the same object. So in the last iteration, whatever you randomize, all of them will get the same randomized value because they all are pointing. They are all pointing to the same object. Did you understood? Understood, right? Because they are all pointing to the same object. Now, what happens when you do s equal to new? What it will do is, every time it points to a different memory, different memory. That will solve the problem. But then it has got a big other problem for me. If I do that, I will lose the RANC will get resetted. RANC behavior gets resetted. So how to solve that problem? To solve that problem, what we have to do first? You randomize, don't do new, do it new outside. Before putting into the mailbox, you shallow copy it to other object and then do it. Randomize it. Then you put it. Now what are you doing? Because of new, each time, how many times you are doing new in this repeat loop? So how many times it will happen totally new? 10 times. That means how many objects will get created? 10 different objects gets created. So hence they all won't point to the same memory. Clear to you? Now if I run it, do you see the same order coming now? 1, 2, 5, 6. So this is one way to solve that problem. Can we write constraints in a module? Can someone tell me? Can we write constraints in a module?
Model is static, right?
Yeah.
Constraints will be done using the
Yeah, basically constraints are dynamic in nature, whereas module is static in nature. You cannot have dynamic constraints inside the static. What are the different types of constraints? You know, simple constraint, distribution constraint, all those lists. You know, what is inline constraints? We know examples, and what is uniqueness constraints? You know, right? We will be doing some of the examples of uniqueness constraint. You will understand that. And what are distribution constraint? Again, we'll do some examples. Iterative constraint, all those things. Okay. What is inverted inside in a constraint? If I use inverted inside, what is the significance of that? Means if I tell constraint a underscore c, a, what does it mean? I think other than that, right? Yeah. So not inside where to use, we need to check that. Can you try it as a homework? whether to use this here or here. That you can check once. Mostly here only, not before the inside. Exclamation should be before the inside. Okay, you can try that. So that means you are telling what? A should not be 5 to 10. It should be anything else other than 5 to 10. We have already discussed what is constraint mode and brand mode, right? Are constraints static or dynamic in nature? By default, dynamic. Is there anything called as static constraint? Are there static constraints? Fine. Constraints are dynamic by nature. Are there anything called as static constraints? Yes, there is a. You can declare the constraints as static. We can declare the constraints also as static. What is the reason? I mean, why do we want? What is the use case of a dynamic static constraint? What is the use case of static constraints? It is same as a static properties and static methods. What is the use case of static properties? All the objects will see the same this behavior. What is that? Constraint behavior, same property value. In static constraints also, all the properties, all the objects will see the same constraint behavior. If you use constraint mode 0, constraint mode 1, it is not going to impact. Basically, in summary, I will give you an example. Static constraint. What is this question number? 22. I wrote one constraint. Another constraint is static constraint. A less or B, let's say I write one more thing for B variable. B less than 5. So I have declared constraint as a static. Now when I instantiate sample as S1, S2, here what happens is both of them will have the same common behavior for this. But when it comes here, I can do S1 dot A underscore C dot constraint mode 0. But for this, I should not do. They even see for S1, I am disabling this constraint. For S2, I am not disabling. For S2, not disabling. For both, this will be applicable. Let's try to do once S1 dot B underscore C dot constraint mode equal to 0. Let's just try once. One dot two. Question 22. B equal to 3. Again, the logic will be what? It will be commonly visible. I mean, S2, since even though you are disabling this will affect for, this will take effect for other objects also. It is other object I am talking about S2. For S2 also, this constraint will get disabled. let's say if I said equal to 1, so now it won't become equal to 1. B equal to 2, the point is it is not taking this constraint effect. Even though you are disabling the constraint for S1, but since B underscore C is a static constraint, that will take effect for S2 also. So point is what? Static constraints are shared by all the objects. So when I disable one of the static constraints in one object, it will be disabled for other objects also. Whereas disabling this doesn't disable S2 constraint, because this is not static, this is automatic constraint. If you ask me, do we really use in the projects? We don't use. It's mostly from an interview perspective. You go to interview, they'll ask you what is static constraint. What is static constraint? A constraint that is commonly applicable for all the objects. Anywhere you disable that constraint mode, any one object, that will be that constraint disable will be applicable for all other objects. Whereas automatic constraints are only applicable to that object only. If you disable, it doesn't apply to other objects. That's all. I think let's do for another 5 minutes and we'll take a break, because I'm just trying to finish off theory discussion. Do you understand RAND case? RAND case is like a case statement where specific statement you want to execute. Something like this, where you want to execute different scenarios. This is one scenario. This is second scenario. This is the third scenario. Based on the weightage, what is the weightage of that value, whatever you have kept here in the case expression statement, right? According to that weightage, this will get executed. Let's say this is equal to 8, this is equal to 1, this is equal to 1. With how much weightage this will happen, this code will execute? 8 out of 10, 80%. This code will execute with how much weightage? 10%. This code will execute with how much percent? 10%. So what is the advantage of RAND case?
We can have a control.
Not just control, the use case will be, we don't need to create multiple test cases. Just by changing the variable weightages, same test can be used to generate multiple different scenarios. Same test can be used to generate multiple scenarios. That's important, right? Because many times you want to reduce the test cases. Your manager may tell, I don't want 100 test cases. Can you bring it down to 40 test cases? How can you do it? Use this kind of RAND case behavior, where using one test case only, you can generate all the scenarios. For example, I go here. I want, what is the first weightage is for good packet. Second weightage is for what? Bad packet. Third weightage is for, which is third one? This one. You can see illegal packet. Do you see? You see bad packet here. Again, let's repeat. What is the first weightage is for? Good packet. Second weightage is for bad packet. Third weightage is for illegal packet. So ill means illegal. So if I want to generate all good packets in the same test case, I want to generate all good packets. What will I use? 1, 0, 0. I'll put this weight equal to 1. I'll put this weight equal to 0. I'll put this weight equal to 0. What will generate? All good packets only will generate. What if I want to generate all bad packets? 0, 1, 0. What if I want to generate everything with equal weightage? 1, 1, 1. Weightage of 1 for good, weightage of 1 for bad, weightage of 1 for illegal. What if I want to generate only good and bad with equal weightage, but no illegal? What will I do? 1, 1, 0. That's all. See, it's so easy, right? Isn't it very powerful? See, instead of creating 7, 8 different test cases, you are able to achieve the same thing with one test case by passing different weightages. How will you handle it? See, when you run the test case, what is this number? 23. When you run vsim work.top plus Ethernet packet, good packet weight, W means weight, equal to 1. Let's say bad packet weight equal to 1 plus illegal packet weight equal to 0. That way what will happen? Good and bad packet will generate with equal weightage, but illegal packet will not get generated. Okay, test name is same test case. If I want to generate only good packet, this much. Let's say you want to generate good with the 10 weightage, bad with 2 weightage, and illegal with 0 weightage. 10 means if you generate 12 packets, the probability that good packet will generate is 10, bad packet will generate is 2, illegal will be 0. Is that clear? So this is actually powerful. Probably you don't use, but you should use it, because in many projects, optimizing the test case is very important. I mean, optimizing the test case count is very important. You cannot keep coding hundreds of test cases. You can always use this kind of techniques where you pass different values and optimize the number of test cases. And here the other thing is what, then you can use scripting into the picture. You can use scripting and generate these values randomly and accordingly run the same test case for different weightages. What is it? These are the sim arguments. Yeah, simulation arguments. Yeah. What we will do is we will use in the module top initial, begin, end, dollar value, dollar plus args. What is that we want to read into? This one, right? So whatever this 1, whatever 10 is there, read into this. Similarly, I can write what is variable ordering constraint. We'll discuss that as we go forward. Constraints
Sir,
are
one
actually
doubt and
important.
last one.
Yeah,
Sir,
please
can
tell
you
me.
share that GVIM,
1 second. What was the question?
sir, for the last one, where we see like, sir, on line number 3, so there are 12 packets, so we are saying 10 good and 2 bad, right?
Yes.
So if we have said like if we have 80% good packet and 10% bad and 10% illegal, so for that, like how we can write in terms of percentage?
811.
81, 811, okay, like that.
Yeah.
So, but that is percentage, right, sir? Here,
That's
this
what.
is
See,
packet.
it's not like that. See, when you generate 12 packets, out of them 80% will be good. Now 80% is 9.6. It won't generate 9.6. It will either generate 9. See, there will always be plus or minus number. It won't take 9 only. It may generate. See, what we are talking is a probability. It will never hold the. It may never. It will never. We cannot guarantee that it will hold the probability always. Plus, instead of generating 9.6, it may generate 11 times. It may generate 10 times. It may generate 9 times. It may generate 8 times. All those possibilities are there. But number will be somewhere around 9.6.
Understood. It will round
Is
off.
that
Okay.
clear?
Yes, yes. Clear.
Let's next talk. Another 3-4 questions. What is variable ordering constraint? That is solve before, right? These are where we use solve before constraints, where we are solving some variable before other variables. Why solve before is required?
There is an equation b is equal to something like a plus c. So prior to that, I should have a value. So we will use that constraint.
No. Generally, what is the purpose of variable ordering constraint is randomize gets over in how much time? Tell me. 0 time. If you are randomizing 10 variables, all 10 variables are getting randomized in same 0 time. That is where solve before will help you. Sometimes you have implication constraints. If I write this one of this constraint, you remember packet type we had, right? Which one was that? Q4. This. Which one should we solve first? Packet type or length? Packet type. Based on packet type, I should solve the length. So this is where I can write constraint, order constraint. Solve packet type before length. You may ask why you didn't use, why it still works. Tool makes the decision. In some cases you have to tell, but in many cases tool is smart to make the decision. It knows that since this is the relation, I have to solve the packet type before length. But there are some specific examples which I am not able to recall now. You have to use solve before, only then it works. Otherwise it doesn't.
Use case will give the implication.
Implication. The left side one should be solved before the right side. Constraints are virtual by default. What does it mean?
We can override the constraints in the child.
Yeah, basically in the derived class. No, anywhere anything can be overridden. The point is, what is virtual nature means? See, not like that. See, virtual is used from a perspective of polymorphism. What is polymorphism? When you override, the overridden object will take the new behavior, new function behavior, not the base class function. What if you don't write function as a virtual? It'll always take the base class function behavior, right? See, understand the point. In case of polymorphism, in the base class, if I don't declare as a function as a virtual, then for that function polymorphism will not take effect. For polymorphism to take effect, you have to specifically tell that virtual function, virtual task, only then it takes effect. Whereas in case of constraints, even if you don't write virtual, it still takes effect automatically. What does it mean? I will explain through an example. Constraints are virtual by default. Let me explain this through this example. Which is a question 26. I have two classes. What are the two classes in this code, in this example? Ethernet packet, Ethernet extended packet. What is the name of the constraint here? Count underscore C. What is the name of the constraint here? Ski. Is it possible to override a constraint? It is possible to override a constraint. You can override a property. You can override a task or function. You can override the constraint name also. See, the constraint behavior is being overridden. Here, what is the count possibility? Less than 10. Here, greater than 50. But you can override. See, this constraint is being overridden here. Is it possible or not? Or will it result in the conflict? Tell me. Will this result in the conflict?
No, no, it is possible.
It won't, because what is
Yeah.
going here, it won't or it won't give the conflict, because this behavior will be overridden with this behavior. That behavior itself will be overridden with the derived class behavior. Now, if I go here, what am I doing in this line? Creating the handle of Ethernet packet. What am I doing here? Extended packet. Now, when I'm doing packet dot randomize, tell me what will be the value of count here? Line number 15. What will be printed? Tell me. Great. No. Packet dot randomize. What value will be printed? What is packet? It is Ethernet packet.
Random
What
value.
value is it?
It's a random value.
It will print less than 10. Do you agree that it will print less than 10, everyone? Next. Extended packet dot randomize. So what is e packet? Extended packet. I am doing e packet dot randomize and I am printing the value. What value do you think will be printed? Greater than 50. Do you all agree with that? Because extended packet has new constraint. It will take the new constraint effect. Now when I go to the third scenario, in third scenario, what am I doing? I am doing the dollar cast of what to what? Extended packet into base packet. Then I am doing packet dot randomize. Now tell me what should happen. See, I haven't declared it as virtual. I haven't declared it as virtual. You understand this concept, right? In system Verilog object oriented programming, for a function to take effect, you should have written it as virtual function. Only then it takes effect. But here in the base class, I did not declare it as virtual. Now, will it take the, when I call packet dot randomize here after the casting, will it take this one or will it take this one? Which one? Second one. That is because constraints are virtual by nature. Means when you cast it, automatically packet dot randomize will take the extended packet behavior for constraints. It will take extended packet constraints behavior because of the default virtual behavior. See, constraints have a virtual behavior. As soon as you did casting, it got overridden with this definition. Simple. Even though you didn't write virtual. That is what I meant by virtual in nature. Now, if I run it, you can see the behavior. So first one should be what? Less than 10. Second one should be what? Greater than 50. Third one? Also greater than 50, because you are there also extended packet is only taking effect. See, 2, 120, 141. So one is less than 10, remaining two are greater than 50. Is everyone clear? You anyone want me to repeat this part of the question? What are the soft constraints? We'll discuss that through examples. You, most of you would be knowing what is soft constraint. Constraints that are okay to be overridden. They will not cause any conflict. If there is no conflict, soft constraint will take effect. If there is a constraint conflict, soft constraint will not take effect. In case of conflict, soft constraints are disabled. What are hard constraints? If there is soft constraint, what is hard constraint? Anything that is not soft is a hard. Any constraint that is not declared as soft is a hard constraint. How to declare hard constraint? Don't write anything. Don't write soft. Automatically it becomes hard constraint. Any significance for? No.
Yeah, what is soft constraint? Can you repeat, Srinivas?
See what is soft constraint is.
In example, with example, you'll understand.
Actually, soft constraints are very, very important. Why they are very important? They will give you default randomization behavior. If I have 31 down to 0, 3 down to 0 length. I can use constraint soft underscore c. Now you may say, do I need to write soft underscore c? No, you can use x, y, z. Doesn't matter. Soft burst length equal to 8. Burst type equal to 2 tick b 01. Address modulo 4 equal to 0. That means what? Address must be always a multiple of 4. In this case, let's understand. What am I doing? Line number 1 to 11, what I have done? I've declared the AXI transaction class. What is the significance of soft constraint is that if user just calls the randomize, by default it will take these values. These are like the default values. But if user want to, let's run this first. Okay, you will understand what is the significance. When I run it, you will see that address will be definitely generated multiple of 4. Burst length will be 8. Burst type will be 1. See, there is a problem. Why there is a problem? Somewhere you did not declare random. What is the problem? Variables are not declared random. Just for convenience, let's not take a very big variable. Let's take only small variable address. Because 31 means it will become very big number. Let's not do that.
You mentioned rand, before.
You got it? Burst length is 8. Burst type is 1. Address is 84. 84 is a multiple of 4. So when you want such default behavior, this soft constraint will be applicable. If anytime I decide that no, I want length to be different, burst length equal to 4. Burst type equal to 1. But address, let it be multiple of 4 only. Let address be multiple of 4. Can you understand this code once? What it will do? So what it will do? Only these two will get overridden. These two will get overridden. This will take effect. No, this will be intact because you are not conflicting it. If you don't conflict, this will take effect. But here you are conflicting. Burst length equal to 4, here you are written burst length equal to 8. So since it is soft, this will get cancelled. This won't take effect. This will take effect. See, this is powerful. Why it's powerful is it is giving you flexibility. If you don't do anything, this will take effect. But if you override, things will take effect. If I run it, can see burst length equal to 4, burst type equal to 1, address is 72. Whereas had I used hard constraint, what would have been, how to write hard? Shall I write hard? Don't declaring the type itself is like a hard constraint. You don't need to write hard. You will get a failure. So how do you make sure that you get the failure, you notice the failure? Use one. It is failing. Why it's failing? It is conflicting, right? It is conflict. What is conflicting? This length is conflicting with this length. Here you are telling 8, here you are telling 4, it is conflict. In this case, what is useful, soft or hard? Soft. See, soft will anyway work. See, if you don't have any conflict, soft will anyway take effect. So that's the reason, whenever you write the constraints inside your class, as much as possible, write the soft constraint. So that will allow you to override them without any conflict. But if you know that this is what compulsorily has to happen always, then use a hard constraint. Soft means what? See, length could have been anything, right? Then you should not make it hard constraint. You should make it soft constraint, so that you will give option to the other user to change the value as per their requirement. Is it clear to everyone what is soft and what is hard constraint?
Okay, Srinivas. Thank you very much.
You can do any number of times. It will take dynamically. The soft will not conflict. Soft constraint will never conflict. If there is any competition, soft will say I'm losing. I lose, other constraint will win. Hard will not do that. Hard says that even I am also equally having weightage, so will conflict. Yes. I think that completes the basic theoretical part of the things. So let us take a break. We will meet in 15 minutes.
This conference will now be recorded.
So now let us go to the other aspect of the today's session, that is problem solving based questions. As I told you, we'll divide these questions into 3 categories: easy, medium, and hard. So easy I don't want to do now. I want you to try it at home. If you don't get it, we'll discuss it in the next session, because as I said, we are limited, bounded by the time. If I start doing each and every question, it will take a lot of time. Okay. So please do that at home. Let's start with one of the medium questions. This is the question. Please read this, everyone, and let's just give a 1 minute time. I probably won't be able to give you 5-10 minutes to do, because in this 2 hours time we have to complete as many questions as possible. So I'll be explaining, but when you do at home, you try to do everything yourself. If you don't get it, you refer to my answer. Okay, please read it. We will give you access to these questions. Okay, we'll give you access to these questions. Today is just we started, right? I need list of people also. Yeah. So let's write. How do you think we can do this problem? Also just write one more thing, that all elements within in range of 50 to 100. How can you do this? First you want first 5 elements to be incrementing in nature, next 5 elements to be decrementing nature. How can you do that? As soon as you see array, what is that comes to your mind? What type of constraint shall I use? As soon as you see array, what is that kind of constraint I should always use?
Iterative.
Anytime you see array, you should always come to mind iterative constraint is required. Iterative constraint. So how to write iterative constraint? Let's see. How to write iterative constraint? For each int a of I, what should I do? First thing is int a of I inside 50 to 100. That's the first thing. What is the next thing? 5 elements should be incrementing in nature. So what will I do? If I is greater than 1, and I less than 5, I less than 5, int a of I should be greater than int a of I minus 1. Means you are telling what? If I is between 1 to 5, int array of 1, element 1 should be a is greater than or equal to 1, right? Yes. Index starts from 0, right? Because of that, int a of 1 should be greater than int a of 0. Int a of 2 should be greater than int a of 1. Till where? Till 4. Till 4, fourth index. Because or you could have written less than or equal to 4. Means inside the iterative constraint, you can use a if condition. One more if condition, what I'm going to use? Greater than or equal to 5 and less than or equal to 9. What relation? Less than. That's done. Let's run this now. S dot int array equal to percentage p s dot int array. Anytime you do randomize, what should I do? Go here. This is incrementing. This is decrementing. Let's say if I say that everything should be multiple of 5, what should I do? All elements should be multiples of 5 only. What should I write? So I want to add one more relation, that all elements should be multiples of 5 only. One more. Let's say if I say that add all elements should be multiple of 5. Second relation. How do I do that? What should I do? Int a of I modulo 5 equal to 0. Like this, you can write lot of relations in the single. See, everything is a multiple of 5 only. You can see. So is this clear to everyone? We can go to the next question. Again, constraint an array, first elements are incrementing in nature. Okay, this is same question. Uh, I'm just picking randomly, okay, some questions because I have some other complex questions to do. Difficulty, we have to go, right? If I don't want to be just stuck to the medium complexity questions. How to do this? Write a constraint to generate this sequence. What generate? What sequence? 0, 1, 0, 2, 0, 3, 0, 5, 0, 6, 0, 7, 0, 8, 0, 9, 0, 1, 0, 0, 2, 0, 0, 3, 0. No, wait, again. No. 0, 9, 0, 1, 0, 2, 0, 3, 0, 4, 0, 5. Mean 1, 2, 3, 4, 5, 9, again 0, 1, 2, 3, 4, 5, 9, that pattern. In between 0 is coming. How will I generate this pattern? Using constraints. Only using constraint.
Position, we should keep 0.
Yes.
In the left increment of the should be increment of the previous.
How to do this? I
Right,
told you
even
for this kind of
indexes.
problem, what is the solution? What is that we have to do for this kind of approaches? Store the earlier generated variable in a static variable. Use this static variable in a constraint to make sure that next pattern is generated. You're getting the pattern? You're getting? You store it. Let's generate it. Okay, let's generate this pattern. Integer array, let's say, p down to 0. And some 51 numbers I want to generate in such a way that our just integer a is sufficient, I guess. Int a is sufficient for now. Static int b, but not random. Static int b is not random. So function void post randomize. Static odd even flag. Which one I want to be zeros? Odd numbers to be zeros, right? No, one. If this is, if I take 1, 2, okay, odd numbers to be zeros. Okay, initially I'll keep what value? Odd. Initially it should be odd, right? It's a 1. So what I will do is, if odd even flag is equal to 1, compulsory. Every time I'm going to toggle it, inverse it every time. For next iteration, it will take the toggled value. Else, it's 0. It's what? Next. Whenever b becomes equal to 10, make b equal to 0, b equal to 1. When, see, what is happening? In the ninth pattern, once 9 hit, where does it go? It goes to 1. It again, see, forget, remove zeros. What is that you have pattern? 1, 2, 3 up to 9, 1, 2, 3 up to 9, that pattern. So, how many times you want to randomize? Let's repeat 30 times or 40 times. Not required, right? We have taken care of everything, right? Let's see. Oh, there is something we are missing. Okay, got it. 0101, it's all generating 0101. There is a mistake. Let's do one thing. Instead of dollar display, I will do what? Dollar right. I will remove this. I'll write, come on. Means everything will print in same line. Next thing is b equal to a plus 1. Static int b equal to a plus 1. Then I'm writing odd even flag. Oh, got it. It should not be 1. What am I doing here? Let's understand. I'll come here. Make b equal to a plus 1. Initially, odd flag will be 1. It's initially odd flag equal to 1. Let's say this is 1. Then since it is 1, a will become 0. A will become 0. When it comes here, a plus 1 is what? 1. B will become 1. Since b is equal to 1, next time what happens? Odd even flag would have toggled. If it toggles, it will become 0. Only one thing I'll do is if is this taking effect? I have to see. It's taking effect. That's why it's giving 0101. Only problem is if it is toggling, let's say 1 becomes 0. If it becomes 0, a will be value of b.
B plus plus we have to do instead of A, B equal to A.
Wait, no, b equal to a plus 1, right? Second, yeah, tell me. When b equal to 10, then we make b equal to 1.
So
What is the value? Yeah,
each and every
B
time
increment is not happening.
we
that's
should
what.
do
See,
B plus
that's
plus.
what we need to figure out why b increment is not happening. So, is it something to do with static? Is it something to do with static? We need to understand. See, let's write here. Tell me.
The condition, can we make it in another b equal 10?
No, wait. Every time it starts, I think it is starting with, I guess it is starting with a equal to 0. See, next time when you randomize, it's starting with a equal to 0. So b always becomes 1 only.
We should take intermediate way.
Not like that. I can do this. Function pre-randomize. A equal to b. Initially b equal to 0. Let's run it. Is a problem. Void pre-randomize. Problem is every time you randomize again, it starts freshly with a equal to 0 pattern. But I think because of pre-randomize, we may be able to solve that problem. We are initializing a with the value of b, right? It is still generating 0, 1, 0, 1, 0, 1. So what should I do?
So B plus plus should work, right? Instead of B equal to A plus.
B equal to b plus 1. Let's see. Yeah, that can also be done. Two times maybe it's increasing. Okay. So if odd even flag is equal to 0, skip it. Don't increment it. Next time I don't want to increment, right? See, only in the next iteration it should become 2. So increment should happen only every odd time, like it's starting with 0. Except for this pattern, everything is working. Initialize with 1. till 9 it came, then again 1 2 3 up to 9. Of course this does require few iterations, but what is that important you should understand here is that how we use these static variables to use it and generate pattern account. Let me again explain. Did you understood what is odd even flag concept? What is odd even flag concept is that every odd number should be 0. Every odd number should be 0. Every odd number should be 0. So what am I doing? I'm keeping a flag. First we are starting with number 1 2 3 1, right? 1 is an odd number, so I am telling that first time you generate should be odd one. It's an odd number. Every odd numbered pattern is what? 0. So when odd numbered one you are generating, it doesn't matter whether the number is 1 3, the first number, third number, the fifth number, seventh number, etc. For all of them I want value to be what? 0. For even numbered ones I want it to be the value of b. What is the value of b I want it to be? 1 2 3 4 5 6, like that. That I'm incrementing. B equal to b plus 1. When am I incrementing it? Whenever odd even flag is equal to 0. Only when during the even cases it should increment, right? For not for odd cases, because during odd cases anyway you are printing 0. During the even numbers only I want for second, fourth, sixth, eighth, I want the number pattern to print. Only during those cases you increment it, and when it reaches 10 you round it off to 1 again. You round it off to 1 again. Then because of this one it will take the value of b and it will print. Okay. Now how is it correlated to this example? I told you that when you want to generate any pattern you have to store it into a static or global variable. It could have been a static variable, it could have been a global variable. Now even you don't even need it to be static. You can do the same example using same example. Move this outside. No need of static in that case. It will work. It will work because here static or global doesn't have any difference. It will also work here. But I would always prefer static or global. Tell me, what should we prefer? Static is preferable because whatever things we are doing is very specific to this class only, right? So why do you want to do outside? Keep everything encapsulated. This is the whole idea of encapsulation. Means keep all the related things into one unit only, don't distribute them. So we would still prefer the previous approach only, where you keep it as a static variable. Is this clear to everyone?
So odd even flag, once you make it 1, so
Every time you're toggling it. You're toggling it. See, first time this will print. Next time this will print. Next time this will print. Next time this will print. Understood? Those attending online, have you understood?
Sir, one small doubt.
Fine. I will give you one homework in this context. Just try that. I'll generate another pattern like this. 0, 0, 1, 0, 0, 2, 0, 0, 3. You got it? For every 2 zeros, afterward number will come. So here for only every 1 0 it came. I'm telling that print one more 0. Do this without referring to my code or my video or whatever. That time you will understand, because Now when I did, you may have felt easy, you may have felt it difficult, but only when you do yourself, you will feel that real difficulty, and that is where you will be able to go to the interview and perform there. Because if you refer to my code and do, you will definitely be able to do, but when you go to interview, you will face difficult again. So don't refer to my code and do, just based on your understanding. See, what you should understand, we stored a static variable, we are storing the values into static variable. See, we are storing values into static variable, that static variable we are using it, that you should understand. Again, you see, this also I'm keeping as static because I want to remember the behavior for the next class also. I want to remember the behavior for the next class also. Write a constraint to generate a real numbers between 3.5 to 5.5. How can we generate? Sorry, can you use a constraint on real numbers? Can I use a constraint on real numbers? Tell me.
No, sir.
All right. So then how can you do that? How can you generate a real random number?
Uh, we
Real
can
A.
keep.
Is it possible I can write real A is greater than 3.5 and A is less than 5.6, whatever is that, whatever 5.5, okay. Is it possible? I mentioned that percentage F. Will it work? Getting, I've written real A and I'm telling between 3.5 to 5.5. Will it work? Okay, it is working. That's good. I mean, I was not aware, actually speaking, real can be randomized. Okay, then it's good. It does randomize between this range. Yeah. But let's say, if I want to randomize with specific precision, right now it's randomizing up to 6-digit precision. How can I randomize it to 2-digit precision? Another way of doing this problem will be, another way could be
Here we can specify percentage clear.
percentage.
Clear.
No, 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 I won't do like that, right? It will do that. No. You let it be real. Rand int b. Let b be inside b greater than 350 and b less than 550. Then in the post randomize, a equal to b divided by 100.0. Generate a number between 350 to 550 divided with 100.0. So it will give you what precision? 2 decimal precision. First you generate a integer number, then divide with 100.0, it will generate automatically 2-digit precision. You see now 2-digit precision only it's generating. What if I wanted 3-digit precision? What if I want 3-digit precision? What should I do? Right now I have done till 2 decimal precision. What if I want 3 decimal precision? What is the range I should use? 0, 5,500. What should I divide with? 1000. 1000.0. Understand, that is important. 1000.0 is important. You can see now it's generating 3.681, 3 decimal precision. Why it's happening is the number will be 4-digit number. So when you divide it with, so with 1000, automatically you will get the 3 decimal precision. This is one type of question. This again generating some pattern. You can check it once. Uh,
Sir,
yeah,
yes, sir, why 100.0, 1000.0 is needed?
because if I don't use 100.0, it'll become integer division. If I do this, it becomes an integer division. So in output of integer division will be integer only. Output of integer division will not be real number. See, it is rounding it off to the numbers,
Yes,
nearest number.
yes.
Whereas if I
Thank.
use, it will become real division. Uh, Implement RAND-C behavior using RAND. This also sometimes people ask what is how to do this, how to get RAND-C behavior using RAND.
We will check the previous with the next one. Equal priority weightage.
How can you give equal priority?
Every will check that the previous value is same one.
Yeah. So what should we do is, anyone want to tell
Queue
how
and
to do
posting
this?
the values.
Push it into a queue and then check if it exists in the queue.
Yeah. Basically, you have to declare a queue and you have to push the elements into queue. You should generate a new value which is not matching the queue.
Yes.
Let's do that. Let's say I have a 3-bit variable. 73. Rand bit 2 down to 0 A. Post randomized, let it be. Okay. Rest all things are same. Repeat percentage 0D. What should I do here? Every time I generate a variable, I want I can make it static. Static bit 2 down to 0 value q dollar. I'm maintaining a queue of values. Every time I generate, what I will tell is A not inside. A not inside value queue. Then what can I do? Value queue dot pushback A and declare the size to be maximum of 7 only. Why 7? Because 2 down to 0 means how many RAND-C will have how many values? 8. I'm making sure that the size is 8 only. So anytime the queue becomes 8, then what you do? What do you do? You empty the queue. You understood what I'm doing? What am I doing? I'm generating pattern A in such a way that A is not inside the value queue. Once I generated in the post randomize, I'm storing it into the queue. Then whenever queue becomes 8, that means it gets full. That means all 8 combinations have generated. All 8 combinations have generated. Then you empty the queue so that it will start a new pattern again, next pattern again. There is a problem, line number 6. So not should be before variable. That our earlier understanding is wrong. Okay. There is a problem. Let's see what is it. I think not of 8 taking. Whole expression I'm keeping not. No. Whole expression should be inside the not. Not just a, the whole expression should be not. That's why I asked you to practice in the tool so that you know what is correct way of practicing. Okay. Now, is it generating the pattern? Initial 8 times. 13740562. Did it generate again? 42053176. Yeah.
Sir.
Yeah. Any questions?
Sir, can you hear me?
Yeah, I can hear you. Please tell me.
Sir, in that code, once can you show me the code?
Yeah.
Sir, you have said in line number 6, A should not be inside the value queue. So,
Yeah.
initially, when the randomization happens, then the queue is empty, right? So, how does it
Yeah,
decide like?
that's what. See, A you don't want inside queue. So every other possible value it will take. See, value queue is not nothing it has got. So that's fine, right? What is the conflict there? There is no problem there, right?
Okay,
A will
so
take
okay,
all possible values in that case. If initially when you start.
okay. So
Clear?
once A takes up a value and we push it inside the queue, the next randomized value of A should not be the one which is present inside the queue like that.
Yes, exactly. Yeah.
Okay, now I got it. Thank you, sir.
Next. This is clear, right? How to get rand C using rand. Let's do this once. I'm not sure whether question is 100% completely correct, but let's see. Write a constraint to randomize a 100-bit variable such that always and only such that uh, always and only 5 consecutive bits are 1. 5 consecutive bits are 1. I think such that always I didn't understood.
Maybe from 100 bit, like all should be one like that.
No. Such that what minimum requirement is that if there is once 5 consecutive ones should be there. 5 consecutive ones should be there. Any number of zeros can be together. Should be like 0, 0, 5 ones. 0, 0, 0, 0, 0 again 5 ones.
Okay.
Yeah, that kind of pattern. Do you think we can do this?
Randomization, we should able to identify one.
Yeah.
Once one is random
Yeah.
getting, then for the 4 consecutive positions we will put one.
Yes. Yeah. So shall we do, or you want to do, or what is it? You want to do as a homework, or you want me to explain this? 100-bit vector, basically. 100-bit variable. Yeah. So let's do this. Question 79. I can take this existing one only. Wherever we stored the values, right, that we can use. But of course, this need to be changed completely. And what is that I want? Bit 99 down to 0. Vector. Let it be. Let's call it as vector. Let it be static in nature. Why static? Because all objects should see the same common value. When I store, I should store into the same common value. Then I will say bit A, static bit B. This odd even is right now not required. Rather required count once. How many counts happened? Let's do that now. Now what I'm going to do is count once is greater than 0. If it is greater than 0 means A should be equal to 1. A should be equal to 1. Means you have started generating once. So you continue to generate once. If it is, you don't write other relation. Let it be, let's write other relation. If it is equal to 0, let's not write other relation. If count once is equal to 5, has already reached 5, then generate 0 for sure. Because I want only 5 ones only I want. And the count 1 should be an integer variable. Then what you do is static int total count. Initialize with 0. Because it's a int, it will automatically start with 0 only. Do you need B? B you don't need. B you don't need. Now comes the important point in the post randomize. What do you want in the post randomize? Vector of total count is equal to A. You're storing the variable into A. Whatever bit you generated, you're storing into the vector. If A is equal to 1, count 1 plus plus. Else count 1 is equal to 0. That's all. Now randomize. What should I print? Vector equal to s dot vector. Percentage B s dot vector. So what am I doing? 5. There is a problem. Failed due to constraint conflict. What is the problem? It's not randomized. Did I not declare random something? Count once. A equal to 1, else A equal to 0. Vector, this should not cause any problem. This one. Okay, total count I think total counts I should keep incrementing, right? Plus plus. This is one thing. But this doesn't seem to be a problem. I mean, I should keep incrementing the total count. It can't cause a problem. But what is the problem? Let's try to see. What is the equations it's trying to satisfy? If count once is greater than 0, greater than or equal, greater than 0, okay. Initially count 1 starts with 0, right? Then what is solutions? You understood? There is no solution. R. Here initially it will become 0, then A will always generate as 0.
But 0 to 5 also we need to.
That's what, no, wait. What if I comment it out? I won't write the other relation itself. So only thing I have to do is,
Here we can't use for each.
wait, I'll just tell you. We should not use for each because it's not a array. Wait, color display. I'll print in the last time. It's printing all ones and all zeros, which is not correct, right? Somewhere here we are missing that. When initially, let's start with the initial thing. When initially count 1 is 0. So when count 1 is 0, what happens? A can be anything. As per this, A can be anything. So when count ones become 5, count ones equal to 5, then reset it to 0. Reset it to 0. But once count 1 starts, then you should make it 0. You should generate once only. Now I think it may work. See, we were not resetting, that was the problem. We should reset, whenever it becomes 5, you should reset it to 0. There is a problem. Here also there is a problem. Let's try to fix this problem. Okay, let's try to understand what happens. Whenever initially when count once is 0, what will happen? This condition will not meet. If this condition does not meet, A can be anything, 0 or 1. So let's say it generates 1. It generates 1, for example. That is where it generated 1. And since total count is 0 to start with, it will store 1 into it. It will store 1 value into it. Then total count increments by plus 1. It will become 1. If A equal to 1, already you generated A equal to 1, right? Count once will become 1. It will become 1. Since count once has become 1, next time, since it is greater than 0, it should generate 1 only. Let's take a scenario where count once become 5. Because it keeps generating, so count once will become 5. When count once become 5, count once will be made 0. So here the problem comes that it should always compulsory 0. Compulsory 0 flag equal to 1. Compulsory 0 flag equal to 1. That means once this happens, if compulsory 0 flag is equal to 1, A should be equal to 0. Because after 5 ones, you want compulsorily 0 to come. So this you are telling what after count 5 ones, So compulsory zero flag equal to 1. In the next iteration, what should you do? If compulsory, after this, when you start again, if compulsory 1 is 0 is 1, you make it 0. Okay, I did not declare that variable. So that will break that pattern. After 5 ones, 0 will surely come. 5 ones, 5 ones, 5 ones. But here there is a problem. Okay, I got the problem. Problem is why it's all zeros, tell me.
Because compulsory flag is 0, we have not defined.
No, we have done only repeat 40. We should do repeat 100. We have only generated 40 times. 100 times. Except for the last one, everywhere you see it generates only 5 ones. See here also 5 ones. Here also 5 ones. Everywhere it generates 5 ones continuously. Remaining zeros can be anything. 1 0, 2 0, 3 0, any number of zeros. See here it generated lot of zeros. So let's again understand this code, how it works. I think this, avoiding this is important. Otherwise, what will happen is it will not generate the required pattern. I mean, you are only putting the compulsory things you want to take effect. Other things, other times, A can be anything. If it doesn't meet these two rules don't meet. In that case, A can be anything. A can be 0 or A can be 1. So you want me to explain this again? What we are doing? See, what we are doing is we are declaring a 100-bit vector. That is because we want 100-bit variable that we have to declare, right? Then what are we doing? We are keeping track of the total count. Why we are keeping track of the total count? Accordingly, whatever you generate, random bit you generate, you store it into that. This is used, this count, total count is used to store the value into that vector. Whatever 1-bit variable you generate, that you have to store into the vector, right? For that you are generating. Every time you generate, you store it, you increment the count. So the next bit should be stored to the next index. Next, what are we doing? You are keeping track of the ones. How many ones got generated? 5 ones or 6 ones. So how are you keeping track? Every time you generate, every time A is 1, every time you generate 1, you are incrementing the count ones. Else you keep count 1 equal to 0. I mean, this is, you are incrementing the number of ones. Keep track of number of ones, number of consecutive ones generated. Then what we are doing, whenever count becomes 5, that means you have reached your threshold. You have reached your threshold. That time you do what? You make it reset it to 0. And compulsory 0 flag equal to 1 means what? Next bit should be compulsorily 0. After 5 ones, compulsorily you want 0. So what are you doing? You are making that one. Based on that one, you are making sure that A is compulsorily 0. And whenever you start the count 1 pattern, whenever it becomes greater than 0, A is 1. So that will ensure that starting from here till count 1 becomes 5, you continue to generate the ones only. Like this. Clear? You want me to explain again? You understand why am I resetting again? Why I'm resetting again? I want only 1 0. I don't want to do like multiple zeros. That 5 ones pattern should break. Continuous one should never happen. After 5 ones, definitely you should break the pattern and 0 should come. This is what is ensuring. after 5 ones, you're compulsorily telling that I want 0. Based on that, you're generating a equal to 0. Once that is done, you reset it back to 0.
That is supposed to be 5 ones, 5 zeros, 5 ones, 5 zeros. It will be repeated like that.
Yeah.
So we should take the consideration of this compulsory.
You should do count zeros also in that case. Can you do as a homework that one? Okay. Another question. What you do? Generate another variation. Question variation. 5 ones. 5 repeating pattern. Do as a homework. I can see if I've done this, we can easily do quickly. But then you won't learn anything if I do it. You please try this. These kind of questions you can do, right? Write a constraint to make sure that every even item in the array is even, every odd item is odd. How to do that? What type of constraint should I use here? Sorry. Yeah. Okay. Yeah. So can you try this, everyone? Basically, you have to use iterative constraint and you have to use if condition. Okay. If condition you have to use. You have to keep track of which index. I mean, you have to use iterative constraint. Then you have to use modulo operator. If condition, modulo operator. Yeah. Can you do this? How to do this? Sorry. There can be different ways of doing it, but when I do, I'll find a simple, little easy way of doing it. So how to do this? Is that any three in the array? Any three should be unique. Same. Rest 7 should be unique. Unique means what? Different values. How to do that? Do this. So array, right? You want array, so you don't need static. Int array of 9 down to 0. Since I want it to be random, rand. Array size, do I need to write? Not required, right? I already said 9 down to 0. Then what will I do? I'll write one more rand int a. Let's say all values are between 0 to 100, something like that. Okay. For each of first thing is for each of int a, I said 10 to 100 or whatever you may say, whatever you want to take it. 0 to 10 to 100. What is the next thing I will do? Unique int A soft unique, let's say. Int A is unique, A is unique. Then I will do what I will do is, if there is little problem, wait. What I did is, I generated int A and A to be unique. Int A will have unique values, A will have a unique value. They won't conflict. Then I'm overriding int A 0, 1, 2 with A values. Then I'm shuffling them. So I'm making sure that 3 values are same. Remaining 7 will be unique. See, remaining 7 are unique. 0 to 3 are 0 to 2 are same. Then I shuffle. They will become random order, right? So then I'll become. See, I said there are different ways of doing the same problem. You can always find a. One second. I'll take your question. Percentage P, I should not use percentage. A also I should write constraint, right? That's the reason. I missed that constraint. A also inside. That is actually the value of A is what is same. Now that I made A is 0 to 10 to 100, that will also take the same value. See what is same here. Tell me. 72 is same. Everything else is unique. So 3 same values. Remaining 7 are unique ones. Does it say that 0, 1, 2 only? Exactly 3 of them. It doesn't tell which 3. Yeah. I shuffled it, right? It will randomize the order of array. Even though I said 0, 1, 2, I shuffled it. So now they will become different orders. Yeah, you had some question.
Instead of raw rating, we are directly giving for each one this index 0, 1, 2.
What else do you think I should do? If I have to apply a array on integers, I have to use for each. There is no option. And this soft is not required. No, I didn't understood. I mean, if you have to use constraints on array, you have to use for each. There is no alternate option.
That is fine.
Yeah.
Below post randomization.
Yeah. Yeah.
So this is we will keep it for each.
Why for each is required?
Inside.
No, we should not do that. That's what. Inside for each, it won't work. It won't work like that. You're telling here I should do int A of 0 equal to A. You're telling. Then this will conflict with this, right? You want in one line you are telling you want unique. In another line you are telling they should match. See, here you are telling unique. Here you are telling matching. Same. Let's try that also. You will see it should fail actually. Because it will conflict. Constraint will conflict. Because it's not able to solve both of them. One where you are telling unique, one where you are telling they should match. I was doing actually same thing, but then I saw that unique I have used, so I should not conflict my constraint. So that's where I am doing it in the post randomize. In post randomize, there is no relation with constraints. So we can do whatever.
Initially, you are generating unique values.
Then overriding with the same value, three positions.
And making shuffling.
Yes, shuffling so that they become random order. So at the end, this is your goal, right? This is what you want to do. We have achieved that. Let's go to some difficult questions. So except for these questions, what I did, I think maybe I've done 6-7 questions. There could be another 25 questions. I want you to try that. Okay. That's what I said. It's not possible for me to do each and every question in the session. Write a constraint for prime number generation. I have tried it. I think it's not possible. It's basically using constraints. How do you generate the prime numbers? Between, let's say if I tell bit below 1 to 100, how many prime numbers are there? 26 prime numbers are there. 2, 3, 5, 7, 11, 13, 17, all that, right? That can be easily done using a function. You write a for loop, you keep doing the if condition, if division with numbers, and you can generate which are prime numbers, which are not prime numbers. Can we do that using constraints? I mean, why these are important is if you go to Google or some companies, right, they will ask these kind of questions. They won't ask simple or medium complex. They will always keep more complex questions only. You can try it. Even I tried. I had a lot of difficulty. I mean, what is difficulty here is to prove that number is prime. You have to do the division. To do the division, you have to write a for loop. You have to write a for loop, right? You cannot write a for loop inside the constraints. It only supports for each. There I had a difficulty. I think it is possible. It is possible. It is possible. We can write for each only. For each. But if condition, based on if condition, I mean, if something is modulo 2, modulo 3, modulo 4, modulo 5, anything becomes 0, then it's not a prime number. I mean, if number is divisible by 3, 2, 3, 4, 5, anything, then it's not a prime number. Shall we try it once? Primary. Okay. Prime Q dollar. Just maintain a queue of prime numbers. Okay. Now I'll take integer a and int current number. Okay. I want to prove whether current number is prime or not. Let's say we'll take number only. So what do I have to do? Not like that. No. Wait. I have to write function pre-randomize. And int division q. Divisor q. Divisor is what? One in the down, right? What I'm going to do? I'm going to fill. So for integer I equal to 0, I equal to 2, I less than number divided by 2, number plus 1 divided by 2. I plus plus. Divisor q dot pushback. Are you getting what I'm doing? I'm filling the divisors into divisor q. Why plus by 2 only? Because I know that if I have to check whether 99 is a prime number, do I need to divide till 1 to 19? Do I need to do division till 98? Not required, right? Because 98, 99 by 98 anyway is not required. Till where I have to do? At max 50. Not even actually 50. 49. Okay. But let's say ideally it should be square root, till square root only. Okay. In system like, is there any way to get square root? We have to check. Wait. 2 to the power 1000. 1 second. Square root. Let's just check once. If we can get square root, it becomes very easy. Square root function in dollar square root. There is something called as dollar square root. Let's check once. Question 85 sqrt.sv. Module talk in module. I'm just checking int a, int b, initial, begin, end. Let's say a equal to 16, b equal to dollar square root of a. Dollar display a. Whether it works, I don't know. Well, let's check. B equal to what? Percentage 0d. Let's try for 14 also. Let's see what happens. Q85 SQRT. Looks like dollar square root is there. 4 and 4. It is rounding it off to upper side only. Rounding it off to upper side. So then it becomes very easy. Why it becomes very easy is I don't need to do till here. Dollar square root of number. That's all. Means if number is 100, I don't need to divide with 11, 12. Actually, my divisors can be only from 1, 2 to 9 only. For to prove that 100 is a prime number, I need to divide with only 2 to 9. Why do you understand? I don't need to divide with 12. Why? Tell me why. I don't need to cross 10 number to prove that some number is prime number. For 100, for 1000 it's different. Why for 100? Why only till 10? Because if it is 12, 12 multiplication will require 12 into some number which is less than 10. 12 into 8 is 96. Then you are already you tried with 8. So since you are not able to prove, you will not be able to prove with 12 also. Did you understood? Square root is sufficient to prove that some number is prime number. Let's say to prove that 100, 10,000 is prime number. To prove 10,000 is prime, or whatever, prime or non prime, let's say 10,001, let's take. What is square root of this thing? 101 will come. I mean, because it will round it off to uppermost number, let's say. So square root will come to after round off. If you are able to prove that 1001 divided by 2 by 3, so on up to 101 is not divisible, then is a prime. you understood this logic? Because if you are not able to divide with 101 properly till 101, 102, 103, they will not be able to do. Because if you increase beyond 102, 102 into 99 it will become. Because other number will be below 101. So you are already dividing with 99. If you go to 103, you have to multiply with, let's say, 97. You are already dividing with 97 and you proved with 97 it's a prime number. So with 103 also you will not get anything else. Do you understand why square root is important here? That will give you the optimal number of divisions. Now what am I doing in the randomize? I'm filling the divisor queue till square root only, starting from 2. Then what I will do is prime constraint or whatever. What will I do for each of divisor queue of if number, you make it static. Make it static. Initially you start with what? 2. Initially you start with 2. If number modulo divisor q of I is equal to 0, what does it mean? Prime flag equal to, what is it prime or not prime? If it is divisible, it's 0. It's not a prime number, right? Since it's divisible. Got it. Else prime flag equal to 1. But this is not correct. This is sufficient. Initially you start with soft constraint of prime flag equal to 1. You start with the assumption that it's a prime number only. Rand bit prime flag. Start with the assumption that some number is a prime number only. Wherever you are able to see something is divisible, you make prime flag equal to 0. Then what do you do? If after all the calculation, if prime flag is equal to still 1, then what do you do? Divisor q, not divisor q, prime q dot pushback number plus plus. You increment the number to the next number. Increment the number to the next number. See, you got the number. That number you have figured out which all things you want to divide with. Then for each of the divisor q, what you are doing? You are checking whether it's prime or not. Based on that prime flag, you are pushing into the q. That's it. So in q, hundred times you do this activity, there is a problem. Line number 17. Equal to 0. Could not find field. Line number 34. Int a. It's not int a. It's what? Primary. Prime q. Prime q. Because the q name is prime q, right? Which are the prime numbers are there is what we have written. Ideally, we should get the prime numbers. There is a problem. There is a problem. It's not working because 4 is not a prime number, 8 is not a prime number, 12 is not a prime number. But see, positive thing is what? We were able to get some numbers. First positive number. Positive thing. Now we have to filter out why this is not working. Let's say square root of, you take 8. Let's do the calculation. Let's take 8. It came to what? Square root of 8 is how much? 2 point something. It will round it off to 3. So 2 and 3, it will do what? It will push 2 comma 3 into divisor queue. Correct, right? It will push 2 and 3 into the divisor queue. And we are assuming that 8 is a prime number. We are assuming that 8 is a prime number. Then you go here. For each of divisor queue, how many numbers are there in divisor queue? 2 comma 3. Is number 8 divisible by 2? Yes. Then prime number should have been 0. Okay. I think in the else case, it's getting let's check this. In the else case, I'm making I equal to 100 so that it exits that loop. Otherwise, in the else case, prime flag can be anything. No, there is a problem. What is the point here is number is divisible by this thing means then prime flag I'm setting to 0 compulsory. The problem is with the else case. In the else case, if I make prime flag equal to 1, sorry, it will make it 1. Thing is, whatever last one, it will take effect always. There is a problem here. What is that I'm doing in the else case is, if it is, okay, wait. I'm setting I equal to 100 so that it exits the loop. Once you prove that, yeah, it still didn't work. How come it missed 5? How come it missed 7? Let me check it once because
Sir,
immediately, yeah.
sir, what is the use of keeping divisor queue as rand? Why do we need to
Sorry,
keep it as rand? Why
which
do
one
we
is
have to
ran?
have the divisor queue? Why do we need to? Yes,
That need not be ran.
because
That
I
need
think
not be
that is
ran.
messing it up. Yes.
Some conflicts are happening.
Prime queue you're not using, but you declared a static in prime queue.
Come again?
The second line,
Yeah,
static in prime queue, right?
yeah. That we are pushing. That is used for storing the prime numbers. First, I am trying to prove whether some number is prime number. That logic is what is important. See, 13, 19, 47, 67. Yeah, these are all prime numbers. Some are missing. So that we have to figure it out. Other numbers, why it's not giving, we have to figure it out. Now, what is happening is, in the else case, prime flag takes a random value. That is causing the problem for us. Else case, see, this is fine. In the else case, what prime flag will take? Random value. It can be 0, it can be 1. There it becoming something. So if I run with a different seed, it will behave differently. I think it should behave differently. Prime numbers only, it will give prime numbers only. You see, now it's giving different set of prime numbers. So we have to solve this part of the problem. How to take care of the else scenario we have to take care. Because if I'm making it I equal to 100, it's again conflicting. See, I is running through the iteration. Why I'm making I equal to 100? I want to exit. I want to exit out of this iteration. Wait, I think I got the idea. I think I got it. I got it. I got what to do. Bit Q dollar. $2 I'll keep. It's a bit. Okay. Wherever you're making it, bit Q dot size. What you do is and bit Q of I equal to what should I set? Let's say I'll set it to 1. Initially bit Q will be all zeros, right? You declare, you make sure that bit Q size is equal to divisor Q size. How can I write? I can write a constant, I guess. Right. What am I doing in that case is, if it is anywhere I proved that it's not a prime number, I'm making it 1. Finally, here I will go, I will not use prime flag. I will use if any of the bit q, or each of bit q of I, if bit q of I is equal to 1, means what? Somewhere it was divisible. So then I will make prime flag is equal to 0. It's not a prime number. After all that, then I will do this. Then in that case, I don't need this. Let's see. Okay. Let's run it now. Now it should generate the prime numbers. 2 and 3. Let's just finish it off. I know we are getting a bit late. Let's just finish it off. See, what I'm doing is I'm generating bit q in such a way that it is same as the size of divisor q, and it's same as the size of divisor q. For each of divisor q, if the number is divisible with divisor q, then I'm setting bit q of I equal to 1. Then I'm going through for each of bit q. If the bit q is 1, that means it's not a prime number. It's not a prime number, right? So I'm making prime flag equal to 0. If prime flag is equal to 1, after all this prime flag equal to 1, then I'm pushing the pushback number. Where are we missing it in this case? Are we missing somewhere here? Let's do $display number equal to percentage 0d, bit q equal to percentage p, bit q comma number. We'll get to know. Okay. Right. Divisor q to percentage P divisor Q. We'll get to know what all numbers we are checking. Let's do one thing. Let's not do 100 times. Let's do only 10 times. Once we are done with this question, we'll stop. Okay. Initially, when number is 2, divisor Q is empty. Divisor Q is empty. So because divisor Q is empty, prime flag we are setting with 1 automatically. So it will be prime flag is 1 by default. So prime flag we are setting it. Okay. When number is also 3, same thing. When number is 4, divisor Q has only one number 2, and 2 is divisible with 4 is divisible with 2. So bit Q will have 1 1. Because why it will have 1 1? Because you are able to divide 4 with the 2. So this proves that it is not a prime number. So 4 is not getting printed. What about the problem? What is the problem with 5? See, my bit Q is filled with 0, 1. So somewhere this logic has a mistake. See, for each of bit Q, in this bit Q, if bit Q of I equal to 1, how come it got divided here? This 1 shouldn't have been there here. You agree? 1 shouldn't have been there here.
Sir, I think that is coming from implication constraint, right? So not from that for each.
That's what. No. The 5 is not divisible with 2, right?
Yes.
Then how come 1 is getting set? This 1 shouldn't have come. That's the thing. 1 shouldn't have come. Check this part. I equal to I plus 1, I less than. It's all filling with all 2's. There is a problem. This divisor Q also has a big problem. Divisor Q itself is wrong. The first thing you should see is what? Divisor Q is wrong. Square root of a number I plus plus I less than square root of a number. It is divisor Q. Int Q. There is a problem here. Square root of a number.
Sir, I think number is set to 2. Always.
Where is number set to 2? No, number is incrementing.
Okay.
Number is incrementing. Number 2, 3, 4, 5, 6, 7, 11, you can see.
Okay.
This shouldn't have happened. That we have to check. I think if we can solve that problem, we can solve other issues. I think we have to solve this part of the thing. Let's check it. Otherwise, I'll check later. First, let's see why divisor Q is filling up with wrong numbers. Why do you think it's filling with wrong numbers? I am starting with 2. I less than or equal to square root of number. Number is fixed. Okay. Let's do one thing. And int square root. Let it be static. Square root is equal to dollar square root of number, so that there is no conflict. For integer I equal to 2 till, let's just do one thing. Let's say j. Tell me.
If SQR, if SQR,
Oh, SQR. Okay. Unless those numbers are filled properly, we cannot do anything. Unless these numbers are filled properly, we will not have anything. Okay, I did not even declare rand, then there is no conflict here, only it's happening. So let's dollar display j. I once not, we'll check it in the next session. Two three solve giving 2 3 Okay, I think it has problem. Let's do one thing. Number divided by 2. Let's keep it simple. No confusion at all. No? Here also this number is not required. Only thing is number of iterations will increase significantly, but it will. But still it has got, see, it is filling. Divisor Q is. Once it is done, I got it. What you have to do is, once it is done, you clear the divisor Q dot delete. Or what you do is s equal to new. That we are missing. That is one mistake. We have to do the new again. Otherwise, it was holding the same values, divisor Q and all those values. See, for 11, divisors are what? 2, 3, 4, 5. This bit Q is a problem now. I mean, with 11 is not divisible with 2, right? But it's still giving 1. 11 is not divisible with 3. It is filling 0. So it's filling randomly for some reason. That we'll have to check. So now the problem is not with divisor Q. Problem is not with divisor Q. Problem is with bit Q. So how bit Q we are deriving? Through a implication operator. So division Q, if I have 2, 3, 4, 5, if I go through 2, number is divisible by 2. So it is not divisible. Okay, I got it. Else. Make it 0. That's it. In the else case, if I don't do it, else case it was taking a random value. Now it will take a proper value. You getting right? We didn't complete that implication operator. We have to write the else case also. So now it gave 2, 3, 5, 7, 11. Did you get all the prime numbers? Now you don't do display, it will still work. You do 100 iteration, you generate up to 100. Mistake was, else case we were not doing. I'll tell you that also. It will give properly. See, 23, 29, 37, 43. You can see these are all prime numbers. Right? So you may say then, huh? 83. Yeah? That we have to take and check. Why it is not generating? We have to check. Okay. That you can do as a homework. Why it's not generating? The problem is the else case. We were not doing this one. If you don't do this one, what was happening is bit Q of I, it was taking randomly 1 or 0. If you don't constrain it, if this condition doesn't happen, the else case it was taking whatever it want, either 1 or either 0. Now how to do 83, whatever that 83, 87 probably, those numbers we have to check. I think 17 is also missing. That we'll have to check that part. you can do it as a homework. What you can do is just generate only up to 20 and you print the divisor Q and everything, you'll get an idea. What is happening, you'll get an idea in that case. Yeah, let's say if I just run it. For 17, what combination comes, you check it. 17 should have what all divisor? 2, 3, 4, 5, 6 up to 9. See, for 17, what should be the divisors? 2, 3, 4, 5, 6, 7. Is it divisible with 2? No, right? It's all coming zeros. Zeros coming means what? Not, it's a prime number. All zeros means it's a prime number. All zeros means this condition won't happen. Prime flag 17 should have been there going by this. See, if all zeros are there. See, for 13, all zeros are there. For 13, all zeros are there. For 17, also all zeros are there. No, somewhere this logic is wrong. Actually. Somewhere this logic went wrong. You got it right. Till here, bit Q we are able to get properly. See, for 19 also all zeros are there. One last thing. Okay. Let's do tomorrow. My point is, I wanted to declare it as a vector actually. I wanted to declare it as a vector. So in that case, you don't have to go through all this. You just check if bit Q is 0. Accordingly, you could finish it off. Here also, what is the mistake? For each of bit Q, see here all bit Qs are there. If bit Q is 1, prime flag is 0. Otherwise, prime flag will be 1 only. So is the prime flag getting randomized? Yes, that's the reason. This is the reason. Prime flag is getting randomized. Now it will work. Did you understand the mistake? We shouldn't have declared it as random. Now if I go and generate 100, you may say, do we have to take so much effort by writing constraint? Thing is, if someone asks you to do using constraint, you have to do this. Without constraints, it's actually more easier. You see, all prime numbers got generated now. 83, 89, 97, 101, everything got generated. 17, 19, everything. Now this print is not required. So we will stop the session here. Any questions? Generating prime numbers. So
yeah, hi Srinivas. This is a general question. Like, can we use Q in for each? Like, as I aware, we lost some data, right?
Please come again.
Can we use Q in for each loop?
We can use, right? We are using Q in for each loop.
Yeah, you are using. That's what I am asking. Like,
no. We can use as long as it is initialized. As long as it is initialized. See, in the pre-randomized, we are initializing it. Then we can use. Otherwise, we can't use it.
Okay.
Since Q is already initialized, we can use it. Okay. That's all. We'll stop session here. Tomorrow we'll continue.